Imagine a world where everything is the opposite of what we know. Instead of electrons, atoms have positrons. Instead of protons, they have antiprotons. Sounds like science fiction, right? Well, this is the realm of antimatter, a fascinating concept that has captivated scientists for decades. It's a realm where the familiar laws of physics get flipped on their head. Antimatter isn't just a theoretical idea, it's real. And the most mind-boggling thing about it? When matter and antimatter meet, they annihilate each other in a burst of pure energy. This incredible phenomenon has fueled countless science fiction stories and captured the imagination of scientists and the public alike. But what exactly is antimatter? How is it different from regular matter? And what makes it the most expensive substance in the universe? Let's dive in and explore the mysteries of the anti-universe. So, what exactly is antimatter? In the simplest terms, antimatter is like the evil twin of regular matter. Every particle of matter has a corresponding antiparticle. These antiparticles are almost identical to their matter counterparts. They have the same mass but carry the opposite charge. For instance, the antiparticle of the negatively charged electron is the positively charged positron. Similarly, the antiproton, as its name suggests, has a negative charge, unlike the positively charged proton. When a particle of matter collides with its antiparticle, something extraordinary happens. They annihilate each other. This annihilation doesn't mean they just disappear. Instead, their entire mass is converted into energy, following Einstein's famous equation, E equals mc squared. This energy release is what makes antimatter so powerful and potentially dangerous. Think of it like this. In a universe filled with matter and antimatter, their constant collisions would create a spectacular, albeit chaotic, cosmic fireworks display. To truly grasp the uniqueness of antimatter, let's compare it side by side with regular matter. Imagine a game of cosmic billiards. On one side we have the familiar matter, the stuff that makes up you, me, the stars, and everything we see around us. It's made of atoms, which consist of protons, neutrons, and electrons. On the other side, we have antimatter. It mirrors matter with its antiparticles, antiprotons, antineutrons, and positrons. Now imagine these two sets of particles colliding. Instead of bouncing off each other like regular billiard balls, they annihilate each other in a burst of pure energy. This complete annihilation is the most striking difference between matter and antimatter. But here's a cosmic mystery. According to the Big Bang theory, the early universe should have created equal amounts of matter and antimatter. However, we live in a universe dominated by matter. Where did all the antimatter go? This question continues to baffle scientists and fuels ongoing research in the field of cosmology. Section 4. Antimatter. The powerhouse of the future? The immense energy released during matter-antimatter annihilation has sparked the imagination of scientists and science fiction writers alike. Could this be the ultimate power source of the future? Imagine spaceships fueled by antimatter capable of reaching distant stars. While still in the realm of science fiction, antimatter does have more practical applications today. For instance, positron emission tomography or PET scans in medicine use positrons to create detailed images of the human body, helping diagnose diseases. Furthermore, researchers are exploring the use of antiprotons in cancer therapy. The idea is to target tumors with antiprotons, which would annihilate with the tumor cells, releasing energy and destroying them with high precision. However, significant challenges remain before these applications become widespread. Harnessing the power of antimatter requires overcoming the hurdles of production, storage, and safety. These challenges make antimatter not only a scientific marvel, but also the most expensive substance on Earth. Section 5. The challenges of capturing a phantom. Producing antimatter is no easy feat. It requires some of the most complex and powerful machines ever built, like the Large Hadron Collider at CERN. Inside these massive particle accelerators, scientists smash atoms together at nearly the speed of light. These collisions produce tiny amounts of antimatter, often just a handful of antiparticles at a time. Storing antimatter is another significant challenge. Since it annihilates upon contact with regular matter, it can't be kept in a regular container. Scientists have devised ingenious methods using magnetic fields to trap antimatter and prevent it from touching the container walls. The cost of producing even a minuscule amount of antimatter is astronomical. NASA estimates that producing just 1 milligram of antimatter would cost about $62.5 trillion. This mind-boggling price tag is due to the enormous energy requirements for its creation and the complexities of storage. Despite these challenges, the pursuit of understanding and harnessing antimatter continues. It's a testament to human curiosity and our relentless quest to unravel the mysteries of the universe. Who knows what amazing discoveries and technological marvels await us as we delve deeper into the realm of antimatter.